start. I was in K6. I spent the summer working with Dominic, and man, he didn't really need my help, but it was really fun. And yeah, so Dominic is a very fast learner. I mean, every day or every time I check in on him, it seemed like he was done with another milestone with this project. But there was a couple times where we sat down and we really went through some debugging together. One of them being using the oscilloscope. So his project has a couple motors, and one of the motors wasn't working correctly. So I saw this as a great opportunity to teach him how to use the oscilloscope. So what we did is we sat down, we probed one of the motors. It was the good one. We saw a good signal. Probed the other one, and we saw a bad signal. And Dominic, being quick thinking, he immediately knew that it was a code issue. So he went onto his IDE and he started looking throughout his code, and he saw that there was a line that was wrong. And so it is this quick thinking that Dominic has that leads to his self-sufficiency. So without further ado, here's Dominic with his object tracking robot.
Hi everyone, my name is Dominic and I'm a rising sophomore in high school. My project is a ball tracking robot, which is a project that's mostly centered around the Raspberry Pi and uses two fundamental sensors, which is the ultrasonic sensor and the Pi camera. And I chose this project because it combined my interest in robotics, and it also had a field that I'm interested in, which is computer vision, which I thought was a pretty cool field. So basically, specifically how it works is that the Pi camera uses a hue saturation value color mask to calibrate the distinct color of this ball to be able to detect it while it's looking around for it. And it also uses the ultrasonic sensor, which displays sound waves and measures the time it takes for it to bounce back to see how far an object is away from it. So now I'll demonstrate the project. So I'll put the robot on the ground in one location, and the ball somewhere else, and then I'll let it go. I'll show how it works. So it takes a little bit of time to boot up, but see, when it starts turning to look for the ball, and then once it's found the ball, it starts moving towards the ball using smart steering to look for it, and then it parks in front of the ball, and when I move the ball around, it's still able to track it and move towards it successfully. And no matter where I move it, it'll always track the ball. So that's the project. So that's the main project, but obviously the main project isn't all what it's about, since this is just a demo project. It's one of the template projects, but to add on to it, I made quite a few modifications. So as you can see in the run, I had an RGB LED on the back of my robot. So when it's red, it means that it hasn't found the ball yet, but it's currently searching for it by turning. When it splashes blue, it means that it's found the ball and it's currently tracking it and looking for the ball and moving towards it. And when it's green, it means that it's parked in front of the ball. And then my second modification was that I created a real-time window in the IDE, which is where you code the robot. And I made it so that you could see what the Pi camera was seeing in real time, which helped debug any issues in the software. And I also made it so that it would draw a box around the ball and highlight the center of the Pi camera's view, the center of the ball, and also have it display some data points, including the distance from the ultrasonic sensor, the offset of the ball from the offset of the ball center and the Pi cam center, and also the ball last seen variable, which is very important for the robot since it enables it to do smart steering. And it determines the ball last seen variable by measuring the offset from the center of the Pi cam's view and the ball center. And then for my third modification, I added an LED strip on the front of my robot, and I hooked it up to a photoresistor on the back of the robot so that in the night, it'd be able to turn the LED strip on based on what the photoresistor was reading. So here I can model it. So when I cover the photoresistor, the LED strip turns on, and when I put my hand off the photoresistor, it turns off. And I made this modification so that I could later integrate it with my main code so that if the photoresistor meant that the room was dark, it would turn the LED strip on and switch to a different calibration for the ball so that it could track the ball in the night. And then some of my biggest challenges were that initially I didn't have any way of fastening my hardware components to my chassis. So I solved this issue by purchasing double-sided tape so that I could effectively fasten them to my chassis and position them in ways that would work well with my robot, including putting my motor driver, which controls the robot, on the underside of the chassis so that it could free up more space on the top of the chassis. And another issue I had, as Taran mentioned, was that one of my motors stopped working, so I used the oscilloscope to be able to visualize the signal within the circuit and figure out that there's a problem with pulse width modulation, which is an inbuilt function within the DC motor that I chose to use that varies the average voltage given to the motor, which effectively changes its speed. And then one of the biggest challenges was that initially when I was working with the LED strip, I was using a transistor so that I could use one of the GPIO pins on the Raspberry Pi, which sends signals to turn on and off the LED strip, but it wasn't working. So instead I did some research and I figured out that you could just hook the LED strip directly to one of the GPIO pins, which is a lot simpler and works much better. And one of the main things I learned at Bootcamp was mostly electrical. I learned a lot about how breadboards work internally and how to use them in projects such as these. And I also learned the essential skill of soldering, which helps make electrical connections permanent and is definitely very useful in the real engineering world. And I also brushed up on how to use the Raspberry Pi and how it connects to your laptop through SSH keys. And then for my next steps, I already highlighted how I want to integrate the LED strip into my main code so that it can enable night vision. But I also want to CAD and 3D print a shell for my robot so that it can look more clean and doesn't have all this wiring mess on the top of my robot. And I'll probably move the LED strip into a more better position. And then one of my long-term goals that I want to, from my knowledge to use, is that this breadboard knowledge will be like all kinds of knowledge from using microcontrollers and breadboards. It's very helpful since me and my friends right now are working on an Arduino project for a competition where we're creating a vibrational stimulant device for Parkinson's patients. So this knowledge will be very helpful in creating that device. And yeah, thank you for listening.
Of all the modifications that you added to your project, which one do you think was the most challenging to add? Or were any of them as challenging as the base project itself?
I don't think they were as challenging as the base project, but I definitely think the LED strip was the hardest modification, since the other two were kind of minor and very easy add-ons compared to making the circuit for the LED strip.
Is there a threshold distance or direction after which you can't detect the ball?
Yeah, it's like around like a 3 feet radius, but after that, yeah, the robot can't really find the color of the ball.
What was your plan with the night vision? Like how are you gonna track the ball you're doing? What are you gonna do with the big camera?
So basically for the main code, I'll check what the photoresistor value is giving and then switch the calibration based off that value so that